we go. So, first off, I want to say right off the bat that I want to thank you guys for the community involvement lately. There's been a lot more comments on the videos, and that just kind of gives me a nice feel of how people are enjoying the videos. So, keep that up if you're enjoying the videos. I'm not going to beg for likes or anything. I don't even think that does anything. Today, I am going to talk about a little bit of the strategy I've taken in creating my game and in coding in general in the recent projects, but specifically with this game Easteria. So I'm going to switch it over so you can see the paint window, and then we'll get to talking, and I'll show you a little bit of things here and there as we get more into the actual topic. If you have any questions, this is going to be pretty coding intensive, I would say, but if you have any general questions about what's going on or you're confused at any point, please feel free to post those in the chat. I may not answer them in this video just because this is kind of assuming somewhat of a coding background if you're listening to what I'm talking about, but I am planning to do some basics of programming videos in the near future. So, sorry, I was making sure the mic wasn't capping out. So, if you have any questions like that, then at least posting them in the chat or in the comments later will allow me to have something, somewhat of an idea of what people want to learn when I go and make those videos in the future. So, as you can see, I have the paint screen open over here, and you should be able to see that. Yes, you can. First off, let me just introduce the topic a little bit. So I'm going to be talking about object-oriented programming. So that's, let's just call this OOP for short. Object-oriented programming. So I'm assuming a little bit of a programming background if you're watching this. So basically what object-oriented programming is that you're taking the data structures and all of the variables you're creating, and you're trying to kind of group them together in a sense. So, I will mention that I work mainly in Python. So, all of my offhand knowledge is usually in Python, but it's generally similar across the board. Python, I believe, makes it a little bit easier than some languages, but also tends to run a little bit slower, so there's gives and takes. But object-oriented programming, at its essence, is organizing data into a repeatable object. So in Python, we call this a class. So what you would actually do is you would create a class. Let's say our class is I don't know, dog. And so you would create this class, and the first thing you do when you create this object of dog is you want to initialize all of these variables that you're associating with dog. So if we were working in a game, then maybe we would, so you'd do this initialization function, and what you do is you list all of these variables. So let's think about what variables would be associated with a dog if we were trying to implement a dog into a game, per se. So this dog would definitely have some coordinate in the space. My games are usually in 2 dimensions, so we'll stick with that. So maybe you have some x coordinate is equal to 0 and some y coordinate is equal to 0. So it's starting up in this top corner over here when you pull up the screen. And what you can do is later on, instead of having a specific variable that's like dog x coordinate, you just have to call this dog.x. So if you wanted to say print to the screen the x coordinate of the dog, then all you have to do is print this value. So this is the object, and then the specific variable that you're dealing with can be called for any purpose that you need. So what's very nice about this is this isn't necessarily like saying x is equal to 0. This is like saying it's like setting up the value 0 so that you can set it equal to a lot of other things. What I mean by that is, let's say that we have 3 dogs. One is Lola, named after the dog that is currently in the room. I also have 2 dogs at my parents' house named Sophie and Bella. So, let's say we had these 3 dogs. We can set all of these name variables equal to dog, and all of them are set up with this blank template that we have of these coordinates. You can also do some situations where when you're initializing this, you can have other arguments in this init thing, init function, and you can have those implemented into your initial values. But in a simpler format, this initial function doesn't need anything, and you can just label all these and then fix it later if you want to. So the beauty of this is that you're setting up this object that can be repeated, and it's like coding once and then just copy and pasting it a bunch more times, but there's not the problem of editing. So it's much like how functions can do the same for actual lines of code. So functions can... sorry, let me get a larger brush here for the eraser. Functions can repeat code very easily and keep track of things for you, but these class objects are very good in doing that for data. So one thing that's beautiful about these class objects is you can also associate functions with them. So after you have initialized the object itself, you can create functions that are associated with this object and can do things to its own variables. So if you were to say you wanted to move this dog, so def move self. So what's happening is you're passing it itself every time, and it can always refer back to these variables because of that. So it's being passed itself, and we could say that we want self.x to increase by 1. So we're going to say plus equals 1, and so self.x will increase by 1 every time we call this. So later in our main function, we can say that, sorry, that's supposed to be a parentheses. We can say that we want every tick, we want dog to move. And at this point, it's almost like writing in English, because you're just saying that you want, or sorry, let's pick one of our names, because obviously we set Lola equal to dog. So now we can say that we want Lola to move every tick, and every time this cycles through, Lola will move 1 pixel to the right. So these are ways that you can create animation in games, is you can have something that updates itself automatically. And so what I do in my game, and this is something that I just learned from searching things on the internet and watching videos myself, is I set up an array of pictures. So I have each individual picture drawn out, and I usually label them in alphabetical order so that it's nice and sorted already when I call those in. So let's say I have this picture of a dog, right? So this is going to be called dog dot whatever your picture name is. So we'll just assume that we have figured that out. And then this next one would be dog 1, and this next one would be dog 2. And so each of these will be little pictures. Oh, and usually I take the background out so that it pastes nicely onto the screen. And so these will be little portions of the animation. So maybe we have the dog just standing here. It's going to be a terrible dog because it's so small. Not that small dogs are bad. Sorry, Lola. But yeah, I just want to get the picture. So maybe the dog is like jumping in this scene, and I'm not sure why it has a rhino horn, but you know, dogs, right? And then it's landing. So the funny thing about this is the way that I set up the code earlier. This dog would be moving to the right, and this is going to be jumping backwards the whole time. But you know, you get the point. So what I do is I set some array equal to this group of images, and it's already in order because these are in alphabetical order due to the numbers, or ANSI order or whatever it's called. And so what I can do is that I can set up a timer based off of how many ticks per second the game is going, and I can have it cycle through all three of these images every second. So in 1/3 of a second, it'll go to this one, and for the second third of the second, it will go to this one, and for the third of the second, it'll go to this one. So every second, the dog will jump once, and it will do this as it is moving. So it'll be moving at a pace of however many pixels per second based off of the frames in the game. So now that's not the most robust way to do this, because if I were to change the frames, that would mean that the person, the actual character would be moving a lot faster, but the animation wouldn't be changing. But assuming that I am satisfied with the frames per second that I am deeming the game to play at, I can base things off of this. So that is what's nice, and I can have that completely handled by my object. So in dog, I could have some function of print, and this print function will figure out which of these three images is supposed to be displayed to the screen, and then display them, and then switch them every third of a second. So this is what's really nice about this, is because I only have to code this for one dog object, and then I can simply set a bunch of other objects a bunch of other variables equal to this dog object. But you can actually go deeper with this. You can create objects within objects, and so what I am doing in the game is I've talked about this a little bit, but I basically have a setup for the map. So if we have them, let's get a chunk of the map, and if you will recall, based off of what I have said previously, I have my chunks set up in 1000 by 1000 pixel areas, and so it's a square chunk, and these are what I'm calling areas. And when I say area, I'm referring to an object that I've set up that is considered an area. Within these areas, we can have obstructions. So we could have maybe the rock here on the path, and we can also have buildings. So if you will recall from the game, I have a start building here in the area, and so you can't run through these obstructions because I've set up walls. Those are also objects. I've set up walls that I can place in either circular or linear patterns. So this building would have 4 walls associated with it, and when I ask to see if the user is colliding with something, it will check with all of its walls. If either of the walls tell the building that the building is being collided with, then the building will reply to me saying that it is being collided with, and the user will not move. So at first glance, you may not notice a difference between an object and, or sorry, an obstruction and a building in this situation. Because if you run into a building, it doesn't work. If you run into an object or an obstruction, it stops you as well. But the difference is that buildings are just a subset. So they're the outside layer of a subset of an area. Because within these buildings, we can have individual rooms. So I haven't shown off as much of this as I possibly could in the game so far because the start building only has one room. But that is enough to give you the right idea. So when you're inside a room, you can only see what is inside the room. So you can no longer see the outside area that the building is within. And by doing this, I can make rooms very dense with objects and keep the game running smoothly. But the room only has to think about what's inside of itself. And so when it asks if the user is colliding with anything, it only has to check with the obstructions within the actual room. So this simplifies a lot of things, and it can allow me to keep the game running smoothly and also facilitate itself without me worrying about rewriting all of this code. You may notice in the game I have doors. So these doors are actually a very simple object. They basically are attached onto a wall, and if a door is present, then the wall, the actions of the wall are negated, but the door also facilitates changing areas. So, like I said, these rooms are basically like small areas, and within a room, if you pass into a doorway, the doorway will now change what area you are in, and you can exit the building. So then you are now in the actual overarching area 1000 by 1000 pixel chunk. So what I have is I have a variable associated with the user, and so the user itself is an object. That's pretty straightforward. I was kind of showing that off with the dog example. So the user is an object, and the user has variables associated with it telling me what area it's in. I usually don't capitalize these things, so user area, user build, and user user room. So at any point in time, I can go back and call these and check which one, what area the user's in, whether the user is in a building, and within that building, which room the user is in. So if the user is not in a building, then it returns a -1 here. That's build. So that tells me that it's outside, because even if the user is within a room, it's still technically in the area. So I'd like to keep that to be true, and so I do. But with the buildings, it keeps track of whether the user is inside a specific building, and then within that building, it keeps track of which room the user is in. So by doing that, like I said before, I can allow the game to only focus on the actual room itself. Now, there are going to be some things where off in the background somewhere, timers may need to be going. So I'm handling that in a separate function, but in terms of actually printing stuff to the screen, checking for collisions, checking if there's going to be a message, any of that kind of fun stuff, I can completely focus on the small area that the user is currently in. So now areas tend to be less dense, so I don't have a problem with it being so large, having a lot of objects. I did have a little bit of a problem. You may have noticed when I implemented the cows, I just put a whole bunch of cows on there to see how it would work, and it did slow the game down. I also had a similar problem with the trees when I tried to implement individual trees and randomly place them throughout the forest. That caused problems because the trees it was trying to print like 50 different pictures to the screen in a small area, whereas opposed to I could print one large picture and it runs a lot faster. Now that does mean it kind of lowers the possibility of a randomly generated map, but with these areas I can go draw something at random and then it will always be printed to the screen. So that's what I ended up doing with the forest. But with it's so convenient to be coding this way, because now if I were to create a new game, the dog is growling at something squeaking outside. If I were to create a new game and I wanted to have something set up like an area or a building or a room, or even if there were just some dog in that game, I can go and take that entire object, paste it into my new game, and all I have to do is create the individualistic variables. So maybe this dog is brown and small, and it's showing up in the bottom right corner of the screen as opposed to the top left. I can go back and reassign all of those variables, and now I have this new character in the game, or in a new game, but the whole coding process has been completely bypassed because I already have this object created. And it's a lot safer than simply copying and pasting whole chunks of code in order to build things. When you have all of the code set up in a class or in an object, it's a lot more organized. So the actual copying and pasting into a new file is a little bit less risky in terms of missing lines or perhaps changing values here and there. So I don't know if there's any questions based off of what I've said so far, but this is the general strategy that I'm using to create my game. So let's go check out the game itself, and we can go see where some of these objects are coming into play. And you may get a little bit of a sneak peek at the latest update, but that's okay. So let me switch the mouse out, and then I'm going to switch the screen so that you can see Easteria. So let me go switch the screen, and we will get it started. So here I have the menu. The menu itself is the menu system itself is an object. So the menu takes care of itself whenever I show a menu. It is it's printing to the screen in its own while loop as opposed to the main game while loop, which means time stops, but I think that's a good thing. So I won't drag too much further on the menu screen. We can get into the game. So here we have a room. This room only has to think about the few things inside of it. So there's a bed, there's a hole up here, there's this crate, and there's this old guy down here. And so with this system, this is essentially an area, and the area only has to think about what is inside of it. Now, this is a room, which is a smaller area, but that's pretty straightforward. So you've seen this part of the game. I'm lucky enough to have gotten a rope, and I will go ahead and get out of here. So now we are in a larger area. So this area, as shown in the picture, has a rock here that it has to think about. It has a building here that it has to think about, all of these cows, and the water over here. Now, it is running a little bit choppier than in the room, but I think that may just be my computer at the moment. It's making a lot of noise, so I don't know if that's the problem. But up here, you can see that we have all of these trees. Now, in this section, I don't actually have the walls set up, but we can go over here, and I do have them set up to the right as well. But if we go over here, you can see that you can run into these trees right here. So if I try to go straight up, I'm keeping my hand on the keyboard and I stop there at that point in the tree. I may be able to show you here. Yeah, you can see that the head is still moving, so that means that I'm trying to move, but I'm running into this. But the beauty of this is that it's actually just one whole object, or one whole obstruction. What I've done is there's a picture that is being pasted based off of a datum of this top left corner, and then all of these circular walls that I'm setting up for the trunks of the trees are just pasted later. Now this is somewhat of a tedious process just because I have to go through the actual picture and check what pixel is the center of the trees, and I'm not trying to get the exact center, I just want it to be relatively close because I feel like people won't sit there and make sure that the trunks are in the exact same spot for every tree, and they shouldn't because trees aren't the same in every iteration. So but that is how the trees work, and by just having one object as opposed to printing an individual object for every single one of these trees, I save data, and I also save runtime because it doesn't get nearly as choppy as it would if I had all of those trees individually placed. So what's cool about this is I have it set up so it still prints the areas immediately around the screen, because the screen is bigger than an area itself in width, not necessarily in height. You'll remember it's 1000 by 1000 pixels. So if I'm in this area, then the cows are still bobbing their head. And you can tell that it's a different area because there's a slight gap in the trees up here, like right here, I believe. So the border of the area is right about here. And so there's also another border of the area right about here. But transferring over those borders doesn't necessarily change anything because I have it so that the visible areas are currently running. So that may become a problem later in time if I'm trying to have something running in the background. But once again, I said that if I want to do that, I'll just set up some timers that are constantly running in the background no matter where you are. Perhaps not in the menu, but at least if the game itself is running, then those timers are running. And so this area has a couple things to look out for. It has this wagon, these rocks, this guy, and so that's pretty much showing everything that I would need to. So I can give you one last glimpse at the menu system, perhaps the settings menu. So here, within this menu, there are several objects. So there are sections, there are pages, sections, and icons. A menu is made up of many pages if necessary. This one has several pages to deal with. So if I click on Save Game, there's a new page that has two sections on it. It has this section of 4 icons, and then it has this one section of 1 icon to exit the menu. And so what this does is it keeps track of what needs to be printed to the menu. And so it's very similar to how I've set up the areas, but it's just a very nice organizational tactic in order to simplify the coding process and speed up the coding process in the future, which is why I am very excited to say that I will be having an update later today, and this update is basically the end of the basics and the skeleton that I need to set up in the background. There's going to be some little tweaks here and there, I'm sure, as I see things that I want to change or maybe upgrade, add more pictures onto the menus to make them more visually appealing, little things like that. But in terms of the actual mechanics of the game, all of them are there right now. So in the next few updates, we should just be getting all content. And I'm very excited for that because I've had a lot of ideas that I want to implement into the game, but it's been a long process in order to get to where I am currently at. So I hope you guys are enjoying the game itself. I will mention now, if it is up on itch.io, if you go look at jonoexplainsthings.itch.io/Easteria. Then you can find this game. It is free for download. Probably download the most recent update, but that's just my opinion. You can do whatever you want. And let me know what you think about it. If you, I don't know if anyone out there is doing Let's Plays, but I know there is one channel that has been doing a lot of Let's Plays recently for my game. That channel's name is Pugsley, and they've been pretty consistent on doing a short update on all of my game updates. So I want to give a shout out to them. But yeah, I'm excited for the near future with the game, and I hope you guys are too. Let me know what you think about how this is going, and I am going to be switching over to the random drawing section. So stick with me.